Welcome to Khetz Tutorials, and in this video I'll be talking about for loops. So let's create a file. Let's call it for loops, or for, I'm not quite sure, but let's go with for loops .py. Okay, so here's our file, and let's talk about what for loops are first of all. So it has two parts, for and loop. So we'll get to this in a moment. Let's talk about the loops of this. Okay, so loop in English terms, or in basic terms, this is imagined as a circular thing, something which goes over and over. It loops, right? It's a common term, it's a common word which is used to describe something which is repetitive. So that is exactly what it is. It tells you that something repeats, right? So something repeats, and let's talk about the for part. What about the for part? Now this describes, or it's the starting point, it's a keyword, and it actually describes how long you repeat. So the syntax of a for loop in Python is something like this. You'd say for, then you'd mention what you want to have loop, and then you'd have something that describes how long you loop. So it's either this, or you're going to actually say that you want to move inside something, which is going to be put in there. Now, if this doesn't make sense right now, don't worry too much. Let's just get right into these for loops. So here's where I want to start. If you wanted to print something 5 times, here's one way that you do it. You'd start at the top and say, let's print hello, and you can copy this and paste it 5 times, right? So you can copy this, paste it. Just skip a line first. Okay. Just going to take that alone and paste it. And let's see what we have. We have 1, 2, 3, 4, 5. And if we run that, it prints 5 times, hello 5 times. But what if I told you there's another way, and which is much more compact compared to this? So imagine if you had to print 1,000 times. This is not efficient at all. And this is where for loops come in. So there are different types of loops, but in this video, we're specifically talking about for loops. So now we define a for loop to print 5 times in this way. You'd say for, then you describe a variable which takes the place of numbers. So you'd say I, for example, or we can call it a counter because it counts, and I'm going to break each part of this down in a moment. Okay, you're going to put 5 in there. Now, this is the point where you really have to get this. So we said that for is a keyword, and it tells you how many times that you actually repeat something. And now if you look at this, we also have counter. Now what is counter? This is a variable. It's a variable name, or it's a variable. What does it store? It stores each of the numbers that are created by this point, which is range. When you say range 5, and remember that when we count in lists and tuples, we start from 0. This means that we'll have a list or a tuple, let's call it a list, of size 5, but starting at 0, it will only end at 4. So now this variable, you can call it anything. This over here can be called anything. You can call it I. That is what you usually have in some programming languages or in some books where you have examples of loops. So this is a for. This is a variable. This creates a list from 0 to 1 less of this number. So 1 less of that number is 4. So from 0 to 1 less of that will be up to 4. And this in just says that this we're linking the variable with this portion. That is what the purpose of that in is. So we say we're going to loop, and automatically or by default it will start at 0. We'll look at another case where you specify where you want to start, But if this range function is used like this, it automatically starts at 0. So now we have 5 numbers, but we're actually counting from 0, so we'll only stop at 4. But at the end of the day, this will loop, or this will repeat 5 times. So the number that you specify here is the number of times that this loop, or the code that will follow the for loop declaration, will run. So expect this print to run 5 times, because that is the 5 that we have over there. But behind the scenes, you should know that this counter variable takes the values 0 up to 4 and not 0 up to 5. Okay, so if we run this, so let's clear the terminal, and we want to confirm that our code expected exactly what we expected to do. So if you look at that, it does the same thing. It's the exact same thing that the 5 print statements did, but we now have 2 lines of code instead of 5 lines of code or more, right? So just to show you what I was talking about in terms of counter, you can also print out the variable that you call. Let's change it from counter to I, which is like a common thing in programming languages. So let's say I, for example, and that would mean that we're printing the values that I takes, and those values, we said those values are from 0 to 4. Let's confirm that by running this 0 up to 4. So actually printing I, as I takes the values that are in range 5. So if you change this to 10, then it will be from 0 to 9. If you change it to 1000, it should be from 0 to 999. So this is how for loops work. The value that you specify, if you only specify one value in range, then it will basically count up from 0. But now there's another form of this. You can specify 2 values, right? So the first value would be the starting value, and the last value would be the stopping value, but it does not include the last value. So if we print I, let's see where I would actually stop. And let's see where it starts. If you look at that, it now starts at 1 instead of 0 because we specified. So this is the start condition. And this other value is the stop condition. But the stop condition, if you look down here, is not included. So you'll always have one less of the upper bound, or the value that you specify. Remember that when you had a range with just one value, it stopped at 5 minus 1. Even when you have 2 values that describe the start and the stop, it will also be the stop value. So this is a stop value if it's specified by itself. Starts at 0, goes to stop minus 1. When you have 2 values, it will now start at the value specified, and it will stop at the stop value minus 1 as well. And that is what we see down here. But at the end of the day, now you have 10 minus 1 values. So you'd have stop minus start number of times. If you want to calculate how many times your loop will actually execute, you're going to say stop minus start. So in this case, we have 10 minus 1, which is 9. If you count these, we have 9. In the previous case, we could use this as well. If you only have range 5, then your stop is 5, and your start by default, you only specified one value is 0, which means your loop loops or repeats 5 times, which is correct. So that is how you can always calculate how many times that your loop will actually execute. And we can take it a step further. And when we take it a step further, you can specify, if you look at this loops and it increases by 1. So each time it adds a 1 to get the next value. What you can do is you can actually skip a bunch of values, and you can count in 2s, you can count in 3s, or whatever step. So these are called step sizes, or steps that you want to use to count. So it's going to start at 1, add 2 to get the next one, add 2 to get the next one, add 2 to get the next one, add 2 to get the next one. And if you look at this, so this is 2, that's supposed to be 9. And now if it adds 2, it will end up at 11, so that will not be included because the stop value is 10. So at the end of the day, you now have 1, 2, 3, 4, 5 values. And let's just confirm that this is what will be the output. So trying to print I, which is the counter, and that is exactly what happened over there, right? So we're adding 2, and we also specified a start value. So to summarize this, this is the start, this is the stop, and this last one is the step, which specifies how many you add to get the next value. So now in this case, if you want to divide the formula that actually tells you the number of values that you have, you'd see that we can also say stop minus start. So 10 minus 1, which is 9, then you divide by the step size, which is 4.5. So if you count this, you have 1, 2, 3, 4, 5. So it's actually rounded up in a way. So how many can you fit in this range or in this number of values that you currently have? And if you look at that, you can actually fit 5 values. Okay, so that is what we have over there. That is how you define a for loop, but it doesn't only do this, because for loops by definition actually step through sequences. And by sequences, those can be strings, those can be lists, those can be tuples. The question is, how do you actually access the values that are in lists? So let's start with lists. So let's say we have names, cats. You have KT. I don't know what KT is, but okay. We have V, and we have, I'm running out of names, I don't even know why. We have Pearl, and let's say these are the names that we have, right? And you want to step through all of these names, or you want to print each of these names, or you want to use them at some point for whatever reason. So we know from the videos that I covered lists that to access each element, so each element you'd say names, then you'd specify the index of that. Let's say this would be KT, which is the first index because you start counting at 0. This is index 0, that's 1, that's 2, that's 3. Okay, so that is how we access each of the elements. But do we specifically have to print them like this if you want to print all of them, like naming all of them? So this should be names going down. The question is, if we want to print all of them one at a time, do we have to go down like this, changing the indices to 1, 2, and 3? And the answer is no. So you can actually use a for loop to access each of these elements. So let's use 2 ways that you can access the elements. Remember that this number in here specifies, or this variable is associated with the range, and we can just write the length of this list, which is 4. So if you look at this, it's 1, 2, 3, 4. If you aren't quite sure what the length of the list that you're dealing with is, you can put len and the name of the list. Remember from the video that I talked about lists, this is how you find the length of the list. It will automatically count the number of values that you have in the list. It will be placed in there, and this would mean that I goes from 0 to 4, right? So it's actually from 0 to 3 because the total number is 4, and this is equivalent to 4 because len names will return 4, and this is the same as just having range 4. Now that we have that, I would take on the value 0, 1, 2, 3. Now that we have these different values, let's just confirm that. So I'm printing I over here, and if you look at that, it's 0, 1, 2, 3. But at the end of the day, we want to access the elements that are inside. So we're going to say names, and we're going to use the index operator, then we're going to have that. So each time I will change, and now that we have that name, or the variable name, will basically take out each of the elements that are in our list. So if you look at that, it accesses each of the elements. And one important thing that I haven't mentioned is this for loop automatically adds or automatically increases the value. So it starts here, it counts, it finishes all the statements, comes back, it counts, it finishes all the statements, and it increments or it adds to the previous value. So the reason that we're actually counting from 0 to 3 is it adds each time when it finishes the statements that are inside. And in here, you can have as many statements as you want, as long as the statements are not repetitive, because the point of the for loop is to repeat something. So it doesn't quite make sense to have something which is repetitive inside, which you can just replace with a for loop. And in a moment, we'll talk about having for loops inside for loops, which is something you can have. So this is how you'd access each of the elements that are in the list using a for loop. And this is not the only way. There is a compact way that you can use. And that way, you'd actually do it like this. We can call it elements so that it has, or we can call it name so that it actually applies to our particular application. And if you look at that, it just makes sense. And instead of that, you just have name. Let's analyze this. We're saying for name, which is a variable name. You can call it just about anything. It's just advisable that you name this according to something that makes sense. In this case, we're dealing with names, so it makes sense to call each name a name. So now we have name in names, and names is that list that is up there. So we're accessing each of the names that are found in names. So for each name, you can read it like that. For each name in names, we want to print the name. So if we clear that, let's see if it does what we expect it to do, and it does the exact same thing. It takes out the name, or it maps each of these names to the variable name. And because names is a list, it just breaks them down into parts. So these are two ways that you can actually use for strings, for lists, for tuples, and all other sequences that are in Python, right? If this were a string, so if it were a name like Khetz, now Python knows that it has to break this down into letters. So for letter, we can call this letter, it's a variable name, you can call it anything, in name, and this is supposed to be a string, so it should have those things over there. Now we want to print each letter. So once you have this, Python automatically knows that it should break cat down into K, H, T, E, T, and Z. That is exactly what it will do if you run the file over there. So you have K, each of the letters are printed on their own. Once again, you can change this back to range. So for letter, and now be mindful of this. Once you change from this to I in range length of name, which you can also do, you should note that the I is now a number, or it holds a number, and you should actually use the index operator. So don't confuse I in range and I in something. This would be replaced by name, right? If I just had for I in name, then that would mean that I'm accessing the letters themselves. But once range is involved, you're talking about numbers, and you should introduce this index operator. So let's run that and confirm that it does the same thing, and it does. So these are two ways that you can use for loops to access sequences or to access elements inside sequences. You know how to define a for loop now using the range, the three types of range, that the one that has one number, the one that has two numbers, the one that has three numbers. Now know how to step through lists, how to step through strings, and any other sequence that you might be working with. And this is how you do it with for loops. So for loops are quite useful because you don't necessarily have to have one statement over there. You can have a bunch of statements, a bunch of different statements. You can have calculations in here, and basically it's up to you what you actually do with for loops. If you want to do something which is repetitive and you know or you don't know, but you can find out the number of times that you should repeat, then this is a good to go to. Now, the last thing that I want to talk about in this video is the concept of nested loops. So this is the term, so nested loops. We can add the for over there to actually specify that we're talking about nested for loops. And what these are is you're going to have a loop inside another loop. And just make sure, so let's erase this name thing and just start from scratch. And let's talk about plain numbers. So you're going to have 5. You can use 5 as a good number. It's a good number. Now just make sure that the variables that you use in these loops are different. So if you look at this, we have 2 loops. The first loop is on the outside. The other loop is inside. How do you see that it's inside? It's actually indented, right? So if you skip a line after defining that, it's actually indented. So you have for, you have the name of a variable, you have in, you have either range or the actual variable name, you have the number or whatever it is that you're going to use to count, you have a colon, and you have the statements. When you press enter, it'll automatically indent if you're using VS Code. Now, in there, instead of having a print statement or any other statement, we have another for loop. So this is a for loop inside a for loop, and you can continue for as long as you want. You can have another one, another one, another one. Just that it won't always make sense to do that. And each time you have another for loop inside another one, make sure that these variable names are different, right? But the question is, why would you need something like this? Or what is the use, or how does this actually work? Or how does it count if you have 2 for loops? And this is my explanation of this thing. So let's use different colors to explain this. Now the orange color is the bigger loop. So let's say big loop, and the red color is a small loop. They're actually equal in size, but let's actually change those names. So orange will be the outer loop, and red would be the inner loop. Okay, let's rather call it like that. So now, remember that we're going to count, we have range with a number. Remember that we're going to count from 0 to 4. So let's count. The outer loop is at 0, and it now tries to execute the statements that are in it. And what is in it is another for loop, right? Okay, so now at count 0, what about the inner loop? Now in the inner loop, we also start at 0. Then we try to execute the statements that are inside. But before we talk about that, I just want to say that pass does nothing. It literally passes. When it gets to it, it passes and it does nothing. That's just the purpose of pass. Now it gets to the pass and it's going to pass. After passing, what will it do? It will actually increment, or it will increase the value of itself. It will go to 1 before it returns to the outer loop and count up to 1. So before it gets to that point, it will increment all of the values of the inner loop. It will loop through inside here. When it's done, that is when it will go back to the outer one to increment or to increase the value. So it will come to pass, increase the value to 1, come to pass again, increase the value to 2. And this statement doesn't necessarily have to be pass. It can be a print statement. It can be anything. I just put pass over there because I don't want to do anything right now. So in the outer loop, we're still at 0, but in the inner loop, we're actually incrementing our values until we reach the last value that I expect, which is 4. We've now reached the last value, which is 4. And once we've reached that, you'll notice that we're now done. So now go back to the outer loop and say, okay, outer loop, I'm done. Now it goes back to the outer loop, and the outer loop is at 0. Now it has to increment. It'll go to 1. After incrementing to 1, it will now go back to the inner loop, and it will increment again. So for each value of the outer loop, it will increment all of the values of the inner loop. So it will increment and it will run all of these values, the inner loop, all of these values in the inner loop, all of these values in the inner loop, all of these. So all of these increments of the outer loop will have all of the increments of the inner loop. So the inner loop will run and finish, and that is when it will go back up to increment the outer loop. That is how nested loops work. So for one increment of the outer one, it will do all of the increments of the inner one, and we can confirm this by printing. So let's print the value of I and the value of j. So let's compare these two values. All right, so these are the values that we have. If we run that, what we have, okay, so for 0 we have 0, for 0 we have 1, and if you look at this, it stays, the outer loop, which is I, stays at a specific value, but j, which is the inner loop, is changing. So we have all of the values for each of the values of the outer loop, and that is what I was explaining. So it will fix the value, or the value of, yes, the fixing is a perfect term. It will fix, or it will stay here, run all of the values of the inner loop, go back up, increment, fix it, run all of the values of the inner loop, go back up, and that is how it works. That is why we have all of these. So you can experiment with this kind of stuff, and it's very useful. Remember, in the previous video I talked about NumPy arrays. It's very useful when you want to step through the rows of the columns of NumPy arrays. I hope you find this video useful. If you like the video, just give it a thumbs up. And if you haven't subscribed, please consider subscribing, and I'll see you in the next video.